Hey guys, what's up? Today we're going to discuss the topic laws of motion. And trust me guys, when I say this, that the points that I'm going to tell you right now is more than enough for you to succeed in your exams with top grade. Here we're going to discuss 5 topics, and these are motion of blocks in contact, motion of blocks connected by massless string, motion of connected block over a pulley, acceleration on smooth surface, and acceleration on inclined plane. So I need you to take your notebooks and write down all the points and tricks which I'm going to teach you right now. And just trust me guys, when you learn this, you're going to pass with good grades and laws of motion will be in your fingertips. So before that, you need to know the basic thing that just imagine a free body with a mass m and it's at rest. Always and always their weight, the weight is equal to mg, right? Their weight will always be attracted towards the earth's surface, hence we should label it downwards, mg. And there's a reaction and normal force acting opposite to the direction of the weight, and we label it as r. When a force F is being applied, we mark it as F, and F is always is equal to MA. So these are the basic thing which you need to remember. So let's start with the first topic, motion of blocks in contact. So consider two bodies, body A and body B. Let the body A mass be M1 and let the body B mass be M2. And I'm applying an external force F. So whenever you're getting a questions or problems with these type of diagrams, first you need to do is to have a free diagram. So since these two bodies are connected, let's separate them. First take the body A with the mass m1. Since the force F is being applied in this direction, there is always an equal and opposite force being acted upon this body, and that is called the frictional force, and it is given with a small letter F, right? So what we write is like F minus small f is equal to the total force being imposed on this body, which is the net force F net. Since a force is being applied onto this body, there will be an acceleration generated. That is M1A. That is a net force. So F minus small f is equal to M1A. Let this be equation number 1. Let's take the second body, M2, which is the body B. Since the force is being acted upon this body A, it is not imposed on this body B. That is, see, we have imposed a frictional force opposite the direction of M1. Similarly, the same force will be imposed at M2 also. I hope you're understanding. So that force F be taken like this, and since it's going in this direction, let it be M2A. Let the net force be M2A. So since these are moving in equal directions, we can put small f is equal to M2A. Let this be equation number 2. Combining this 1 and 2, we can substitute 2 in 1. So we get F minus M2A equals to M1A, because F is equal to M2A. I just gave this M2A over here, over this position. So this is what we get. So F is equal to M1A plus M2A, and F is equal to, since A is common, we take A outside, and M1 plus M2, and the acceleration is equal to force by M1 plus M2. We got an equation. So whenever you see a problem regarding two blocks which are in contact and a force is being applied over here, the acceleration and you're asked to find an acceleration of this, so the formula you should use is this one. And if you don't remember it, don't worry, take the free diagram method. Take one block at a time, find a formula at a time, and then later substitute it. So you will automatically come and derive it to the acceleration part. So let us do some problems regarding this so that you will understand much more better. Two blocks of masses 7 kg and 5 kg are placed in contact with each other on a smooth surface. If a force of 6 Newton is applied on the heavier mass, the force on the lighter mass is. So see guys, this is the block which is having the lighter mass, and we need to find the force being acted upon this block. So if you either you can go by direct method, or else you can derive it by taking each block at a time. So I'm going to take each block at a time. Let's see. Let's take the 7 kg block first. And a 6 Newton force is being applied over here. And it is more, since force is being applied, there is always an acceleration accordingly. So 6 Newton force is being applied onto this block. So the block will move with a mass of 7 kg into acceleration, which is of the formula ma. Okay, and when the block is being exerted by an external force, it always experiences a frictional force, as I said earlier. So let's derive the formula. Since these forces are acting opposite in direction, we put 6 minus F is equal to the net force, which is 7 into A. We'll take this as equation number 1. Okay. Next one is, since a contact force F is being acted in this direction, it always acts in the opposite direction also, so as to neutralize and balance. Understand? So we'll take the 5 kg block right now, the second one, and a force small f is being acted onto this direction, which is the contact force, and the block is moving in a direction of a force having 5a, which is again the formula of ma. So we'll take small f is equal to the net force, because they are moving in equal directions, so it is equal to 5a. This can be considered as second equation. And what is our question? We need to find the force on the lighter mass. That is, we need to find this small f. So let's put it together. So equation 2 is being substituted in equation 1. So I gave this f 5a over here. So 6 minus 5a is equal to 7a. 6 is equal to 7a plus 5a. 6 is equal to 12a. And acceleration is equal to 6 by 12, which is equal to 1 by 2 meter per second square. Always do not forget to put units, because these units carries great marks, and when you don't put these units, you're going to lose half a mark, where half a mark is quite important. So a is equal to half meter per second square. We got this. Now what the question is, they're asked to find the force on the lighter mass. That is the force being acted over here, 5 kg, that is the small f. So we know f is equal to 5a. We got the acceleration half meter per second square. We gave this over here. So f is equal to 5 into half, which is equal to 2.5 Newton. And that is the force being imposed on the lighter mass. Another method where we can find the acceleration is that we know net force is equal to net mass into acceleration, where acceleration is equal to net force by net mass. We know the net force being given over here is 6 Newton, and the net mass is 7 plus 5, which is equal to 6 by 12, which is equal to half. We can also find acceleration by this method, and once you find the acceleration, you just give it to this equation. So either you use the free body method or by the direct method to find the acceleration and then later substitute. So this is a concept and the problem regarding this concept. I hope you're understanding. And another question I have given here is for you to do it and comment it in the comment box. I hope you are understanding everything what I'm telling. If there is any doubt, comment down below. Do share, subscribe, and like, and the rest of the topics will be uploaded very soon. Thank you and have a nice day.